Alzheimer's disease is a progressive brain disorder that attacks one's memory and is in danger of becoming a significant health concern. Did you know that between the years of 2000 and 2015, deaths from Alzheimer's have increased 123%? In 1906, Dr. Alice Alzheimer's analyzed symptoms in his patients, including memory loss, and observed shrinkages within nerve cells. Then in 1931, Max Nolan and Ernest Ruska completed their construction of the first ever electron microscope with 1 million times magnification to study brain cells. In 1993, the Food and Drugs Administration approved their first Alzheimer's drug, Cognex, which treated the symptoms. Next, in 2003, the National Alzheimer's Disease Genetic Study was created with the goal of identifying the risk gene associated with the disease. Then, in 2013, the G8 Dementia Summit launched an international effort with the goal of finding a cure by 2025.
According to the amyloid hypothesis, accumulation of beta amyloid in the brain is the primary influence driving Alzheimer's pathogenesis. Researchers propose that when beta amyloid clumps together, it forms deposits in the brain, which triggers a neurodegenerative cascade that is observed in Alzheimer's, although the hypothesis has never been universally accepted. A common counterargument to the amyloid hypothesis is that plaques are found in the brains of many healthy elderly individuals. The weak correlation between plaque accumulation and disease severity has also been used to criticize the amyloid hypothesis, since symptoms are linked more closely to the characteristics of tau tangles than they are to amyloid beta plaques. The greatest argument, however, is the disappointing track record in clinical trials of drugs that target beta amyloid.
Early drugs for AD were acetylcholine inhibitors, Tacrine, Acrosep, Exelon, and Remenon. Later drugs were semaglutide, avagistat, and taraflurbil to inhibit cleavage by gamma secretase, ribosistat and OM99-2 to inhibit cleavage by base 1 aspartate proteases, bepanezumab to clear amyloid beta plaques, and monoclonal antibodies such as aducanumab and solanezumab to target amyloid beta and tau for degradation. Memantine is hypothesized to act by blocking reabsorption of the neurotransmitter glutamate. If administered before the patient develops symptoms, it may slow or prevent disease progression. Intranasal insulin's growth factor properties make it effective as well.
A new theory today is centered around tau proteins. Tau is found in brain cells, and its role is to provide a structure, like a train track, to help the cells clear any accumulation of unwanted and toxic proteins. When tau is abnormal, these toxic proteins, including amyloid beta, accumulate inside neurons and begin to exert toxic effects inside the cell. The cell then does its best to spit out the proteins into the extracellular space. Contrary to what has been believed in the past, it's the proteins that couldn't be spit out and remains inside the neurons that destroys them, not the plaques building up on the outside of the cells. So why does tau stop functioning? Errant genes or aging may cause the process to begin, which could be a possible explanation for the confusing clinical observations of older people who have plaque buildup but no dementia.
Another theory is the viral hypothesis. There is data suggesting that herpes simplex virus type 1 is a cause of Alzheimer's. The theory is if this virus were to eventually reach the brain, repeated reactivation there could lead to accumulation of damage manifesting at a late stage in life. This is consistent with the onset of Alzheimer's, usually in older age. Studies have been conducted demonstrating that this viral infection causes a striking increase in intracellular levels of amyloid beta and phosphorylated tau, the two main markers for Alzheimer's.
In 2016, the global market size for drugs treating Alzheimer's disease was an estimated $2.35 billion. Four drugs dominate this market, the first being Namenda XR by Allergan, which is the most popular but is also the most expensive. Memory by Daiichi Sankyo has only 16% of the market, but also costs the least to the consumer. Next is Exelon by Novartis and Aricept by Eisai and Pfizer, taking about the same size of the market. Finally, the other 20% of the market is shared by smaller drugs. The market is projected to grow as new drugs targeting the cause of Alzheimer's disease exit phase 3 clinical trials.